Question 10A. A cottage is on a bearing of 200 degrees and 110 degrees from Dogbe's and Manu's farm respectively. If Dogbe walked 5 kilometers and Manu 3 kilometers from the cottage to their farms, find correct to Roman figure 1 2SF, the distance between the two farms. Roman figure 2 to the nearest degree, the bearing of Manu's farm from Dogbe's. Solution: a cottage is a small house or a small hut or a small court. Now you can access the cottage from the two farms. From Dogbe's farm, the bearing is 200 degrees. So if Dogbe's farm is somewhere here, from the north, 200 degree is in the third quadrant. So you have the cottage down of Dogbe's farm. Now for Manu's farm, the bearing is 110. 110 is in the second quadrant. That is also down of, so the cottage is also down of Manu's farm. So you have Dogbe's farm here. From the north to the third quadrant is 200. Now why is this place 20 degrees? Now the whole of the first and second quadrant is 180 degrees. So if you add 20 to 180, it gives 200. That is why from the end of the second quadrant to this line is 20 degrees, and by implication this angle is also 20 degrees. That is alternate angles. Then from Manu's farm, the bearing from the north to this point is 110 degrees. The whole of the first and second quadrant is 180 degrees. If you have 110 out of it, the remaining place must be 70 degrees. So by implication, this angle is 70 degrees. If you add the two angles, you have 90 degrees. 90 degrees. Now the distance between the two farms is represented by S, and because one of the angles is 90 degrees, we have a right angled triangle. So you can find S, the side that is facing the right angle, using Pythagoras theorem. From the question, Dogbe's walked 5 kilometers from the cottage to his farm, and Manus walked 3 kilometers from the cottage to his farm. So let's find the distance between the two farms using Pythagoras rule. So the first question is to find the distance between the two farms. Let the distance between the two farms be S, and because this angle is a right angle, you can use Pythagoras rule. And you have the longest side S, that is S squared equal to 5 squared plus 3 squared, and that is 25 plus 9, you have 34. To get S, you take the root of both sides, and S is equal to square root of 34, and that is 5.83095. To 2SF, you have 5.8 kilometers. Roman figure 2 of part A, you have to find the bearing of Manu's farm from Dogbe's. That means Manu's farm from Dogbe's, you go to Dogbe's farm. you go to Dogbe's farm and you start movement from the north to the line that join the two farms together. Already from here to this point is 200, so you just need from here to here, which will represent with theta. So once you get theta, you add it to 200 degrees. So you have it that the bearing of Manu's farm from Dogbes is 200 degrees plus theta. We can get theta easily since the triangle is a right angled triangle. So tan theta is equal to opposite over adjacent, and that is 3/5. If you divide, you have 0.6. Yeah, you have 0.6. So you have 0.6. This implies that theta is the arc or inverse of tangent of 0.6, and that is 30.96 degrees. Therefore, the bearing of Manu's farm from Dogbes is 200 degrees plus 30.96 degrees, and that is 230.96 degrees. To the nearest degree, you have 231 degrees as the bearing of Manu's farm from Dogbes farm. Question 10b. A ladder 10 meters long leaned against a vertical wall S meters high. The distance between the wall and the foot of the ladder is 2 meters longer than the height of the wall. Calculate the value of S. Solution. Of course, you have BW as the wall and the height is S meter. The ladder FW leaned against the wall, and the distance between the wall and the foot of the ladder is 2 meters longer than the height of the wall. Height of the wall is S meters. Distance from F to B is 2 plus S meters. What you have is a right angle triangle. So we get S using Pythagoras theorem. The hypotenuse is 10. Then you have the other two sides. So you have 10 squared equal to S squared plus 2 plus S all squared. If you simplify this bracket, you have these results alongside other terms. Already we have a quadratic equation. In order to solve, one of the sides needs to be 0. So let us transfer 100 in. So you have S squared plus S squared is 2S squared plus 4S plus 4. You transfer plus 100, it becomes minus 100 equal to 0. If you subtract, you have this result. You observe that 2 can divide through so that the terms can be reduced. I mean the coefficients. So you have S squared plus 2S minus 48 equal to 0. You can factorize. Now, if you compare this with AS squared plus BS plus C, you will see that A is equal to 1, coefficient of S squared, B is equal to 2, coefficient of S, and C is equal to minus 48, the constant term. And whenever A is equal to 1, you look for two factors of the constant term, that is 48, that the sum is plus 2 in S, and the product is minus 48. Such factors must be plus 8 minus 6. you write them in terms of s and replace the middle term with them in this form. The purpose is to get 4 terms so that you factorize by grouping. The first 2 terms, the first group, the last 2 terms, the second group. Ensure that you use a plus sign to separate the 2 groups. From the first group, s is common. If you factor out s, you are left with s plus 8. From the second group, minus 6 is common. You factor it out, you have s plus 8. You equate everything to 0. Clearly, s plus 8 is common. If you factor it out again, you have s remaining here and minus 6 that will form the other bracket. You equate the 2 factors to 0, and when you collect like terms, you have s equal to minus 8 or 6. The height cannot be negative. Therefore, the value of s is 6 centimeters.